Hey physics class, we got video, I don't know, 3, 4, whatever we're on now, talking about refraction. And so this next little video is going to talk about how to kind of do these questions where you have all those like lines moving in front of you. It's basically going to tell us like how do we actually use this refraction, and can we tell what the new angle is going to be? Can we draw it? Can we tell what the new velocity or tell what the new wavelength would be based off this thing? Now, to do that, we have to use this formula, okay, which is talked about as proportional refraction. What the heck does proportional refraction mean? What that means is, and I talked about this in the first video, there are 3 things that get affected when the wave goes into a new medium. So let's say that, again, sound wave went from air to water. What are the 3 things that change? The wavelength would change, the velocity would change, as well as the angle that it is going, like the angle that it hits it at is also going to change. So all these 3 things change. And they all change basically at the exact same ratio, or they all change proportionally exactly the same, which is why we're able to use this. So if I were to give a really easy example of what I mean by this, let's say you had a wave that had, again, a wavelength of 2, a velocity of 4, and an angle of 20. Okay? If we knew that the new wavelength, when it hit this new medium, changed to 1 meter, like basically went by half, they're all going to stay the same at that very exact proportional level. So instead of 4, I'll have a velocity of 2. Instead of an angle of 20, I'll have an angle of 10. Okay? So there's one proportional way to kind of look at this. I'm going to show you guys how to use this formula for our actual worksheet and go through a couple examples there. But there's basically, again, this is why this works, because they all change the same exact proportion. Okay? Let's bring in a worksheet problem here. Let's turn me on. There we go. This one. So let's first kind of dive in here. So you can see here, I love this little box. I put it into, let's put this a little lower for a second. You can kind of see here that, again, we have wavelength 1 and 2, velocity 1 and 2, and angle 1 and 2. Talks about how to have this formula here. So there you go. I can't use this box when I'm looking here because it's going to be outside. So I'm going to make a little list on the side here instead of the box. Just that way it's bigger on the screen for you guys. So let's go down, try and figure out how the heck to use this. I need a little smaller. No, that's not what I want. Something's happening. Okay, back to regular. Okay, I want this to look like this. So now I can actually figure this out. So, first off, well, it gave me the speed somewhere at the top. Somewhere at the top, it gave me the velocity. The original velocity is 3. Okay, so I'm going to, on here, write down the 3 things that I need. Wavelength 1, wavelength 2, velocity 1, velocity 2, angle 1, angle 2. I need all these 6 things. Okay, now 4 of them you can actually just find. It gave me velocity 1. So velocity 1, 3 meters per second. How do I find the other, like, how do I find wavelength? How do I find angle? Well, wavelength's not too bad. Literally just measure it. Okay, now I would try and measure on here because it's blowing up on my screen, but literally all you do, this is one wavelength, a crest to a crest, a crest to a crest. So just measure one of them. It's not 7 centimeters on your paper, but I did do it on the paper, and you'll find that at the bottom here we have a wavelength of 2. So in between here should be 2 for you, 2 centimeters. And so I have wavelength 2 centimeters. And if I did this, I think it's 1.2. Yeah, I have like 1.2. So on your paper, it should be something like 1.2, okay, centimeters. The angle is a little harder to find, okay? What you have to do is you have to make a normal line, okay? And this is the best way that I do it. I like to make a ray using this side here. So this side lines up just nicely like this, right there, okay? So this would be like the arrow that comes in. And then I have this arrow over here. There's the refractive arrow. Okay? So off of this, let's actually make a normal line. Okay, so right where it meets, right on the side here, we're going to make a normal line. So again, put it there. Normal line means at 90 degrees, I put a dot. And so this normal line is 90 degrees. What I'm doing. The nice thing is, because it's 90 degrees all the way through, I can extend this line on the other side. If you do this again, it'd be exactly at 90. Okay, so now let's find my two angles. I have an angle here between my ray and my normal, and I have an angle here between my ray and my normal. So again, line up your protractor with the normal line. So you can see it's on the normal line, and then it's up-ish 40 degrees. So I had, well, never mind, I had 35. It was right between 45, it's 40 and 35. You can kind of see it's right there, closer to 35. So I have 35 here. Again, I'm not going to be too crazy in the angles. If you have 40 here, even 42 or 30, not a big deal. Okay, I'll figure it out. Last one here, let's find this angle. Okay, put it on the normal. It's hard to see. I'm going to just make sure this ray is a little longer. It'll be easier for you guys with your protractors that I see through. And I got it about 20, okay, which is I have for mine. Okay, which is exactly the same one I did down here. So that's how you find your angles, though. It's kind of annoying. Make your ray on the side, make a normal line, find that angle. Make a ray on the side, make your normal line, find that angle. So now that I found my angles, I have 35 degrees, 20 degrees. Okay? How do I find this velocity? Now, you do not have to, the fun thing I should say, the good thing about this formula is you do not have to use all 6 of these, okay? If, I know, I have to find velocity, so I'm going to use this middle part. Now, I can just cover up one of the sides and then just use the information that I have for that, So I have wavelength 1 and 2. I also have angles, but I don't really want to work with the angles right now just because it's a lot of sine work. So I'm going to use this part of the formula to find V2. I have this. There's my one variable, and so awesome. Okay? You could also make it look like this. It could be the same answer. I'm just going to do this to actually find my V2. Okay? So you don't ever have to use all 6 of those. You're only going to use like up 2 of those parts to find. So I'm going to do this. I need to find V2. So I'm going to use these 4. So for my wavelength 1, I have 2 over 1.2 equals, my velocity is 3 over V2. So there's what I'm going to use to actually figure out my velocity. Now when I go 2 divided by 1.2, I get 1.66. Okay, so I got 1.66 repeating equals 3 over V2. Swap these. My V2 is going to equal 3 over 1.66. When I do that, I get an answer of 1.8. Okay, 1.8 meters per second. And so that is what's going to go over here, 1.88 meters per second. Okay, so now I've answered all 6 parts of this question. Okay, I've got both wavelengths, I've got both velocities, both angles, and I was able to figure out how fast this is moving now. It's moving quite a lot slower. Instead of 3, it's now moving at 1.88. Okay, and if you were to ask this question, like, which one is the more dense, or which one is the shallow part? Well, this is more dense. Okay, everything's moving slower in this part, and we have a smaller angle, which means everything's moving slower. It's the more dense part. All right, so there's one example. On my next video, I'll do one more example. Thanks, class. Oh, I gotta get in front. Now you can see my back. That's okay.